Okay, so today we're going to be doing a bit of preamble for WM9. What you're going to be doing in class is actually a titration to analyze the purity or the amount of aspirin that's contained in an aspirin tablet. Okay, um, and so that's basically called an aspirin assay. Okay, so you're analyzing the aspirin tablet to um, determine how much actual aspirin, so acetyl salicylic acid, there is in that tablet. Okay, this is actually going to be the last video in this What's in a Medicine series because obviously lesson 10 you hopefully did as a cover lesson. So there was the PowerPoint uploaded. You went through that just because of the days that fell on. So this will be the last one. We're going to sort of have a discussion about when we will be carrying, picking this back up if we're going to. It won't be for Materials Revolution, so that will be taught as normal. Um, but we will see, about feedback and things if it's worth carrying this on at a later date. Okay, so there's only a few questions for this video. It's not going to be a very long one. So just have a look through those and we'll get on with it. So what you're going to be doing in lesson is basically performing a series of titrations on a solution of aspirin. So you're going to get an aspirin tablet essentially, um, make a solution from that, and then titrate it against a base, okay, an alkali, because as we know, okay, the aspirin has this carboxylic acid group, okay, um, and within that carboxylic acid group we have that hydrogen which can be donated. Yeah, so it has this acidic hydrogen that can be donated. So um, aspirin can act as an acid because of this carboxylic acid group. So what we're going to do is react that carboxylic acid group with an alkali, okay, to form obviously a salt, um, and that's basically our titration reaction, okay, and that should tell us, okay, when we do some calculations, how much aspirin there was, and then we can compare that with what the mass of the tablet was, and we can get the mass of aspirin in the tablet against the mass of the actual tablet itself to see the percentage of aspirin in there. So what I'd like you to do really is just read through WM6 and have a look at that results table. So really sort of, because it is quite a big results table, have a look at all the different measurements you need to take and you know just make it clear the steps that you're going to need to do things in when you're weighing, when you're taking the mass of your samples and things. Make sure you know what order you're going to have to do that. So just read through, annotate, or highlight anything that's you need to remember or is that will help you, and just come back to the video. Okay, so hopefully that all makes sense to you. It's quite clear, quite simple activity, but just to make sure you're happy with that. Um, so we're just going to discuss very quickly about uncertainty. So uncertainty is basically a range that you give. Whenever you give a value, you give a range, so a plus or minus range, in which that value your reading should lie within. Yeah, so it's like a difference, plus or minus difference in a value, saying that you are very sure that your reading will lie within that range. Okay. Um, Most pieces of equipment have this uncertainty value. Okay. Um, and it will say plus or minus a certain amount. Okay. Um, and I've put two things here that you're going to be using. So the uncertainty in a balance that's measured to 3 decimal places is 0.0005. Okay, so that's the uncertainty. So it's plus or minus that. Okay, the uncertainty in a burette reading is 0.025. Yeah, so plus or minus 0.025. So what you do, just to work out the percentage uncertainty, is the uncertainty in the reading, which is one of these two, okay, whichever piece of equipment you're doing, divided by the measured value. So that's just whatever you measure. Yeah. So if you're weighing a mass of say 1.1 grams, that would just be the measured value 1.1, and then times it by 100, and that gives you a percentage uncertainty for that one reading. Okay, but that's the important part. It's just for a single reading. So if you do multiple readings, so like in that table, you'll see that you're taking the mass of the thing as a whole, and then you're removing your sample, and then weighing the filter paper or whatever it is again. That's two separate readings there. So you're actually going to get an uncertainty twice. Yeah, so you would actually, add those two uncertainties together because you're having two separate measurements. And the same is true for the burette. You measure a reading at the start, so you take a start value and then you take an end value, and that's how you get your titer. So the uncertainty in a burette reading will always need to be multiplied by 2. Yeah, so you work out your uncertainty, and you'd have to just make sure that you double that. Okay, so say you measured uh, added say 20 centimeters cubed, then you'd do 0.025 divided by 20 times 100, and then you times that whole percentage by 2 because you're taking the uncertainty from the first reading, the initial reading, and then for the final reading. Okay. And it's very important to do uncertainties for your measurements because it allows you to say with confidence that the true value lies within that range, and it's then very good for when you're plotting graphs and things. You can then see how your data falls and lines of best fit, etc. So hopefully that was all clear. Most of it was just you reading through that activity actually. So make sure you write any notes if you're not 100% clear on what you've got to do. Uncertainty should be straightforward. You've done that before, obviously. So just be clear about that. And yeah, that's it. So hope it all goes well. Good luck with the practical, and that's it. That's the end. So if you could just let your teachers know if there was anything about this whole process that you maybe liked or didn't like. You could just say, at the end of the lesson, we will be doing some sort of formal questionnaire at some point as well, hopefully. But if there is anything that you think is quite important to say about, any comments about it working or not working or in certain ways, that would be greatly appreciated. And yeah, thanks very much.